And we are back. So what we have is the classic Pythagoras theorem question that you guys will run into for related rates. We'll work through it together and we'll discuss everything that's going on with this, and hopefully it will all make sense to everybody. So what we're going to do here is we're going to start with what's this question asking and what's this question telling me. A man starts walking north at a speed of 1.5 meters per second, and a woman starts walking west from the same point at a speed of 2 meters per second. At what rate is the distance between them increasing 1 minute later? So, when we're looking at this, first thing that we're going to do is we're going to draw that diagram. I have my initial point, and a man starts walking north, which is upwards at a speed of 1.5 meters per second. So if we're talking about the speed, if I label this distance y, we're going to say that this is dy over dt, or rather it's the rate of change of y as with respect to time. A woman starts walking west from the same point at a speed of 2 meters per second. So now she's walking west, and we're going to label this as being x. So we know that my dx over dt is going to be 2, and my dy over dt that I forgot to put a value in for is 1.5. If we're looking at the distance between them, we can very plainly see that I have a right angle triangle here. Now, one more point that I'm going to bring up is, if you remember from the previous question, we made the statement that the negative refers to a decreasing value. It doesn't refer to the direction that we're going in. So when we're walking west here, you guys will notice that I label that as being a positive value. What we need to do is we now need to find an equation that will give us a way of relating all of the values that I'm using for this question. So if I label that as x, that as y, I'm just going to label this other side to be z, and we can see that the Pythagoras theorem relates all of my values quite nicely. At this point, what we're going to do is we want to again take the derivative of this to get the equation of how everything changes. So I take the d over dt of this, or the derivative with respect to time. Now in each of these, what I'm going to have to do is I'm going to need to abide by my chain rule. So we get 2x, and then that multiplies by dx over dt, plus 2y, and that multiplies by dy over dt, equals 2z, and that multiplies by dz over dt. So now what we've done is we've created an equation where we have 6 variables. Well, we need to start filling some of these in. I see that my dy over dt is 1.5, my dx over dt is 2, so that's 2 of them down. Now, the next thing that stands out to us about this question is the fact, and I'm going to use multicolor on this one, it says 1 minute later. So looking at my 1 minute later, that means it's been 60 seconds. If we're walking at a rate of 1.5 meters per second for 60 seconds, what does that tell us? That tells us that we've gone 90 meters. Subsequently, if we're walking for at a rate of 2 meters per second for 60 seconds, that's going to give us a total of 120 meters that's covered. So that's telling me that my y is going to be 90 and my x is going to be 120 meters. Now, we now have what our dx over dt, our dy over dt, our x, and our y are going to be. From there, we're going to need to find one more of these variables. At what rate is the distance between them increasing 1 minute later? So that means that it's going to be the dz over dt that I'm looking for right there, telling us that we're probably going to be trying to find that z value. How would I find that z value, you ask? Well, if we filled in, whoop, we're going to go back to black for that one. If we fill in the triangle with the values that we've already found, we found that the y is 90 and we found that the x is 120. So I can use my Pythagoras theorem, x squared plus y squared equals z squared, or 90 squared plus 120 squared equals z squared, giving us z equals 150 meters. So that has filled in what my other value is going to be. Now all we're going to do is go through the process. So I have 2 multiplied by my x, which is 120, then multiplied by my dx over dt, which is going to be 2, plus 2 multiplied by my y, which is 90, multiplied by my dy over dt, which is 1.5, equals 2 multiplied by 150, multiplied by my dz over dt. Now I have faith that all of you guys can rearrange this and put this in your calculator, but we end up with dz over dt is going to equal 2.5 meters per second. So this is our basic Pythagoras theorem question for related rates. I hope you guys enjoyed, especially the extra color that I used. Thanks, guys.